Hello friends, today's question. A sufficient long plank of mass 4 kg is placed on a smooth horizontal surface. A small block of mass 2 kg is placed over the plank and is being acted upon a time varying horizontal force F.5 T, where F is in Newton and T is in seconds as shown in figure. The coefficient of friction between the plank and the block is kinetic as well as static is same, that is mu. At time t is equal to 12 seconds, the relative slipping between the plank and the block is just likely to occur. So we are going to find out three things. The coefficient of friction mu, the acceleration a versus a time graph for the plank and the block, the average acceleration of the plank in the time interval 0 to 15 seconds in the figure. So this is figure 2 kg block, 4 kg block. A force F, which is time varying, is being applied on 2 kg and the friction exists only between 2 and 4. There is no friction between the 4 and the surface. So let us first of all say that both are moving together with the acceleration, same acceleration, that is A. Blocks 2 kg and 4 kg move together with same acceleration, which is given as A. So we can draw this is 2 plus 4 force F and they are moving with acceleration A. So we can write this as that F will be equal to 6A. From here we can say that acceleration will be equal to F upon 6. Now let's draw the free body diagram for 2 kg as well as 4 kg. The friction will exist between only 2 and 4 kg. So this is 2 kg block, 4 kg block. Force F is being applied on 2, so there will be frictional force Fr towards the right and equal and opposite Fr will be acting on 2 kg block. So let us discuss first of all for 2 kg. For 2 kg block, force F, frictional force Fr, acceleration A towards the right. So we can write this equation as F minus Fr is equal to m2 multiplied by A, and m2 is 2 and acceleration is 5 F by 6, so we write 2 F by 6, and from here we can find out that our frictional force Fr will be equal to, this cancel out, this becomes 3, we're taking F as common, so this will be 1 minus 1 by 3. So we can write this as F frictional force Fr will be coming equal to as, this will be 2 by 3 F, and it is given that our force F is 0.5 T. So from here we can say that you substitute value of F, so Fr will be equal to 2 by 3 into 0.5 multiplied by T. So from here we can say that frictional force Fr will be equal to, this will be 10 1 1 by 3t. Okay, and for 2 kg block, this will be m2g, and upper direction there will be normal n, and we have this frictional Fr. So we can say that our value of friction Fr will be equal to mu into n. Let us call this n2. n2 is m2z, so this will become mu into m2 multiplied by g, and m2 is 2 kg, so this will be mu multiplied by 20. So from, if we equate these two equations, we can say that 1 by 3t is equal to mu multiplied by 20, and from here we can say that our mu will be equal to t by 60. So we can find out the coefficient of friction at time 12 seconds. Okay, we can say coefficient of friction at t equal to 12 seconds. We get mu is equal to 12 divided by 60. From here we can say that mu will be equal to 0.2. Next, we are supposed to find out that the acceleration versus time graph for the plank and the block. Okay. So it is stated that relative slipping starts at time is equal to 12 seconds. Let us start with part B. So it's given that relative slipping starts at time t is equal to 12 seconds. So let us divide this analysis into two parts: when time is less than 12 and when the time will be greater than 12. Okay, so we can say for t less than 12 seconds there will be no slipping. No slipping between the 2 kg and 4 kg. Therefore, they both travel with same acceleration. Therefore, they move with same acceleration. Let us suppose that is given as A. From here we can say that our acceleration A will be equal to acceleration A will be equal to 0.5 divided by 6 multiplied by t. So this gives us that acceleration A will be equal to, this comes at approximately 0.033 t, and Let us find out for t greater than 12. Let us find out for second part. For t greater than 12 seconds, they will be slipping will start, and obviously they will traveling with different accelerations. Slipping starts between the two. Therefore, they move with different accelerations. Let's find out the respective values. For block, let the acceleration be equal to a1. So this is our block of 2. A force F is being applied on it, and we have this Fr, and it is moving with acceleration a1. So we can write this equation as F minus Fr will be equal to m2 multiplied by a1, and we can write the equation for a1 is equal to F minus Fr divided by m2. Okay. So as there is a slipping, Fr because of slipping, Fr will be equal to Fr max, and whose value will be coming equal to as Fr max will be equal to as Fr will be equal to Fr max. Okay, then we can say for 4 kg this will be Fr and Fr max. So we can say that our Fr max, and it is moving with acceleration a2 in this direction. So we can say that our Fr max, let me write it here, for 4 kg Fr max will be equal to m4 multiplied by a2, and this is 4 multiplied by a2, and Fr max we already know is our 4. So we can say that Fr max is equal to 4. And from here we can find out that our a2 will be equal to 4 upon 4, which gives us a2 is equal to 1 meter per second square. And from we can write that equation a1 will be equal to F is 0.5t minus Fr, and Fr is our 4 divided by m2, that is 2. So this will be coming as a equation a1 will be equal to, sorry, here it will be plus. This will be coming as 2 plus 0.25t. So we can now draw the graph. We can divide it into two parts. This will have time, and we have this acceleration, and and for t is equal to 12, for t less than 12, both will be traveling with same acceleration, and the equation was governed by a is equal to 0.83 t. This is basically a straight line, and at t is equal to 12, the acceleration of a2, a2 is 1 meter per second. So let me write it here, 1 meter per second. So 4 kg will be moving this direction with a constant acceleration now, because it becomes independent of time. And for A1, that is our block, it will be moving with a increased, you can say, slope. So this will be a plank, and this will be a block. Block is of 2 kg and plank is of 4 kg. So this is the part B. Now in the part C, the average acceleration of plank in the time interval 0 to 15 seconds in the figure will be. So we are supposed to find out average acceleration. So there we are, this is meter second square, and the time in seconds. Part C. In part C, we are supposed to find out average acceleration between time 15 seconds. So let's once again divide into two parts. Our first is for time lies between 0 and 12 seconds, and both travel with same acceleration. Both move with same acceleration, therefore they are moving the same acceleration. So this is 2 plus 4 of force F with the acceleration A. Let us write it for capital A rather, easy to differentiate. So we can say that F is equal to 2 plus 4 multiplied by capital A, and we can write this equation as A, F is 0.5 t divided by 6. So we can find out here that velocity V will be equal to 0.56, integration is 0 to 12 seconds t dt. So this gives us V is equal to 0.56, this will be t square divided by 2 from 0 to 12. We can write that V will be equal to 0.56 into 12 into 12 divided by 2. So this goes by 6, 6 goes by 6. So we get V as 6 meter per second. And now let us find out for time which is greater than 12 but less than 15 second, for time greater than 12 but less than 15 seconds. This is our 4, and we already know that Fr in this case will be equal to Fr max. Let us suppose it is moving with the acceleration of A1. We can say that Fr max is equal to 4 multiplied by a1. Fr max is 4, so a1 will be equal to 1 meter per second square. The corresponding velocity, let us suppose, is v1. So we can see that v1 is equal to u1 plus a1t, and the initial velocity will be the final of this part. Okay, so we can say that here u1 will be equal to v, which is equal to 6, because the block is already in motion. So we can say that v1 as Planck is already in motion. So we get v1 is equal to 6 plus a1 is 1 multiplied by time, that is 3 seconds. So we get v1 is equal to 9 meter per second. Now we are going to find the average acceleration. Average acceleration is equal to v1 minus v divided by this will be v1 minus, let us suppose this as v prime, and divided by this will be t2 minus t prime. So this will be coming equal to as 9 minus 0 divided by 15 minus 0. So average acceleration will be equal to acceleration average is equal to 9 by 15, and that will be coming approximately as 0.6 meter per second square. So this completes the question. Thank you.